Good morning, good afternoon, and good evening to all of you, and maybe even good night, depending on which time zone you are listening and viewing this webinar. Welcome to the webinar organized by 2WCOM System in Flensburg, Germany. My name is Berry Eskes, and I will be your host for today's webinar. This webinar has been prepared by Anke Schneider, Joost Schultke, and Berry Eskes. Today, we're going to talk about the pros and cons of MPX transport over IP and over satellite and how to deal with the cons. This webinar will take about 25 minutes. During the presentation, you can ask your questions in the side panel of GoToWebinar. Please use the questions chat function. At the end of this webinar, my colleagues from engineering will be available to answer all your in-depth technical questions. Of course, you can also contact us after the webinar by phone, email, Microsoft Teams, Zoom, or any other video meeting. So what are we going to talk about today? We will start with a brief introduction on 2WCOM systems. Then we will let you enjoy a brief flashback in time. And we're going to ask ourselves, why should we use MPX over IP transport? Then we talk about the advantages of MPX over satellite, in particular µMPX over satellite. We will show and explain the pros and cons, and of course, take away the cons. And most important, answer all your questions. So, who is 2WCOM? We are a broadcast technology-driven company in the north part of Germany, in Flensburg, very close to the Danish border. More than 25 years of experience, and we are a manufacturer, supplier, and support you also in system integration. We have a lot of know-how and expertise in all kinds of standards for the radio broadcast industry. Not only hardware, such like audio over IP, DAB, FM, and RDS, but also software solutions, including cloud-based and Kubernetes. We are with 30 people and 75% of our people are engineers, so we are a real engineering company. Philosophy. We have a progressive attitude. We are all very open to innovations, not only in terms of topics like cloud-based radio or multimedia production, but also in terms of team interaction. Here, for example, we have adopted Scrum in order to plan complex work packages well and to be as transparent as possible to the team. We are agile and competent because we react fast to the feature request and adapt quickly new technologies such as NMOS. Of course, we can't realize every request, but everything which is relevant to the audio broadcast is usually implemented sooner or later. Our quality standards are very high. We have established an internal quality control procedure, and our products are also regularly tested by an external company in terms of IT security. In addition, Kubernetes has brought us a significant step forward when talking about stability and IT security with respect to our MOIN software solution. Precision is extremely important, especially in use cases such as signal frequency network, where we achieve synchronization to the microsecond. Communication with our customers is very important to us, because apart from all technologies, it's always about the people behind it and their needs. So for the newbies in FM MPX, let's take a closer look at the MPX signal. The left part of the picture shows the frequency range 20 Hz to 15 kHz, which is reserved for mono audio. A bit to the right, you will notice the stereo pilot, which is modulated at a 19 kHz carrier. Between 23 and 53 kHz, the left minus right audio component is placed. On the moment your radio detects the stereo pilot of 90 kHz, it will automatically process the mono signal from 20 Hz to 15 kHz and demultiplex it with the left minus right audio component. Your car radio will then switch to stereo mode, and you will enjoy the unsurpassed audio quality of FM. At the right side, RDS data is carried on a 57 kHz data carrier. This allows your radio to display station name, activate traffic announcement, and most important, switch your tuner to other FM transmission towers without you even noticing it. It also carries TMC, which is data for your navigation system with traffic information. As you will understand, MPX is a complex signal form. Even the slightest disturbance will have a huge effect on the transmitted FM signal. So we have to be very careful when transporting MPX over IP. You do not have to be worried about this, because 2WCOM has over 20 years of experience, so you're in good hands. When did we start with MPX over IP? In 2012, WCOM Systems has introduced the first product offering MPX over E1 transport. E1 was used by virtual all broadcasters using microwave links to connect their studios to the transmitters. E1 offers 2 megabit lines and is a synchronous distribution method, perfect for MPX transport. E1 got obsolete and is getting replaced by IP. In 2014, we introduced the first MPX over IP systems with analog MPX in and output. By using a smart compression technology designed by 2WCOM, the bandwidth could be reduced from 3.5 megabit to 1.7 megabit. In 2014, that was a major breakthrough. In 2017, this product was upgraded and digital MPX inputs and outputs were added to the product. In the year 2020, only 2 years ago, we have introduced our completely new designed modular MPX over IP platform, offering a MPX codec, a µMPX codec, a stereo generator, an RDS encoder, dual IP streaming technology, and secure IP transport in only one rack unit. This year, we are proudly introducing µMPX over satellite, including a range of features such as dual MPX decoding, MPX switching for regionalization, and TS-GPIO forwarding. Why should we use MPX over IP? Well, aside from the technical part, let's take a closer look at the operational aspects. It allows broadcasters to process the audio on one central location. It avoids time-consuming trips to reconfigure audio processors at the transmitter site. It reduces the number of equipment and therefore lower power consumption. So this seems like an efficient solution. So how do we do this? So why should we use µMPX over IP? Well, it reduces the required bandwidth from a whopping 3.5 megabits to only 320 kilobits, while still maintaining a very good audio quality. µMPX is not yet an official broadcast standard, but has been implemented by a number of broadcast vendors, so it's becoming a de facto standard. This means that you are not caught in a proprietary compression method available by only one vendor. You are free to choose. 2WCOM has implemented µMPX in embedded technology solution, which offers high reliability, excellent audio quality, and a low delay. Let's compare MPX over IP to audio over IP. Take a look at the upper block diagram. The most common method of transport until today is audio over IP. Audio over IP is effective and, due to the low bandwidth use, a cost-effective way of feeding audio to the transmitters. Audio over IP requires at the transmitter side an audio over IP codec, a stereo generator, an RDS encoder, and in many cases a sound processor. How about MPX over IP? We're now going to take a look at the lower block diagram. You will notice the difference in equipment at the transmitter side. MPX over IP requires only one unit at the transmitter because sound processing is done at the studio. So how about MPX over satellite? Linear MPX takes 3.5 megabits, which is huge, so satellite transport will become very expensive. The brand new MPX2DS, MPX over satellite receiver from 2WCOM, supports µMPX decompression starting at just 320 kilobits. This groundbreaking technology allows transport of MPX over satellite links while maintaining a very good audio quality. It can also be operated in a mix of IP feed and satellite distribution. Take a closer look at the block diagram. You will notice that only one device is required at the transmitter side, so a very effective solution. Okay, and how does it all look from the inside? Let's start with the encoder. The encoder basically holds three major functions: capture, encoder, and transport output. Let's start on the left side of the block diagram, stating capture. This is the part where MPX from the studio enters the 2WCOM MPX2C encoder. The MPX2C supports both analog and digital MPX input. You will also notice a 1 PPS PTP input. This is to synchronize your distribution network via GPS. This input is only in use when you wish to operate your MPX distribution in single frequency mode or FSFN mode. This adds time-stamping in the PCM samples, so the MPX2 decoders can play out the MPX synchronous at all decoders. Now let's go to the mid section of the block diagram called encoder. The MPX2C offers 3 modes of MPX compression. Option number 1 on the top, converting the uncompressed MPX to a lower sample rate. This allows MPX transport at a bandwidth of 1.7 megabits per second. Option 2, transport the MPX uncompressed. This requires a bandwidth of 3.5 megabits per second. And option 3 compresses the MPX to so-called micro MPX, allowing transport of MPX over just 320 kilobits per second. MPX is now ready for transport, so let's go to the last section called Transport Output. Option 1, encapsulating MPX as elementary stream or IP RTCP stream, offering timestamping for decoder synchronization. After encapsulating, the IP stream will become available as 2 identical streams over 2 separate IP Ethernet ports. µMPX adds additional robustness to the transport. Option 2 adds SRT or RIST for secure, reliable transport and encryption to the outgoing IP streams. SRT and RIST are requiring a bidirectional IP connection. Option number 3, encapsulate MPX over IP in an MPEG-2 transport stream for transport over satellite. So, after having this digested, we would like to move on to the MPX2DS decoder part. This picture shows the block diagram from the MPX2DS as a one-channel MPX over IP and satellite decoder. The decoder basically holds 4 major functions: input, transport, decoder, playout, and MPX processing. Let's start on the left side, stating input plus transport. The MPX2DS offers 2 methods of transport: terrestrial IP or satellite. The left side shows the dual Ethernet ports for MPX over IP transport and 2 LNB inputs for the optional satellite tuners. Depending on your infrastructure, µMPX can be transported via IP, via satellite, or hybrids, for example, satellite as main and IP as a backup. After MPX2DS has ingested the MPX over IP streams, the dual streaming and µMPX do their work and the MPX over IP is ready to be decoded. This is done in the same manner as with the encoder. The MPX2DS will also be able to decode SRT and RIST, secure, reliable transport solutions. SRT RIST are only available for Ethernet IP data interfaces, as this requires a bidirectional IP connection to allow SRT to request resending lost packets to recover IP streams. The playout function is recovering the timing and synchronization information and takes care of a synchronous transport to the last section in the MPX2DS decoder. The last section is called MPX processing and allows the MPX to be prepared for transmission. In case external RDS is required, the MPX RDS cutoff filter can take away the remaining RDS carrier and replace it by a local RDS. The bottom side shows the UCP input via IP or RS-232. The MPX2DS can also hold an internal RDS encoder for regionalized RDS. So that was a lot of information and I hope that you are still with us. So what about capital expenses? CAPEX shows the investment required to purchase the equipment. Because of 2WCOM's modular and compact design, the MPX over IP solution requires only 1 unit at the transmitter side. So how about the operational expenses? OPEX shows the costs required to operate the equipment. Because of the reduced number of units, obviously less rack space and energy costs per transmitter side are required. Also, less units means also less rack space rental and maintenance costs and spare parts. Let's not forget the impact on our environment, the green footprint. Due to the reduced number of equipment, the energy costs are reduced dramatically. In these days, where cost for electricity has been doubled or even tripled, this is a very important part when talking about OPEX. Please contact your service provider to calculate the exact savings in operational expense. And of course, we are happy to support you in that. Are there any threats? Yes, there are potential threats: bandwidth, audio synchronization, and transmission robustness. So let's take a closer look at them point by point. Bandwidth is very important to the broadcaster, as this has a direct impact on the operational cost. As mentioned earlier this webinar, uncompressed MPX distribution and even 2WCOM's MPX compression does not satisfy the radio station with limited bandwidth. We are facing bandwidths typically between 1.7 and 3.5 megabits per second. µMPX, however, does offer an extreme low bandwidth and a good audio quality. How is microwave MPX different than other MPX over IP technologies? Well, think of regular MPX like a CD or linear WAV file, so an audio file, and µMPX like a compression method like MPEG-4 AEC or any other compressed format. So now, what is µMPX? Well, µMPX was specifically designed to compress MPX in a way that it can be transported over a very small bandwidth. At 320 kilobits, blind listening tests have shown that it's extremely difficult to hear the difference in audio quality between µMPX and non-compressed MPX. Most people even can't hear the difference. So how does µMPX offer this high quality at this low bitrate? Unfortunately, the compression method of µMPX is a well-hidden secret from stereo tools. Just to give you an impression on how we believe it works, the µMPX encoder compresses the stereo audio, RDS data and pilot carrier to µMPX format. We believe that the audio component is compressed in the same way as, for example, MPEG-4 AEC. Furthermore, the 19 kHz pilot carrier is important because it is the cornerstone for MPX. How is µMPX turned back to a standard MPX output? We believe the decompression works as follows. The µMPX decoder receives via IP or satellite the following components: stereo audio, RDS data, and pilot carrier, with of course information on the exact phase of the 19 kHz carrier. Specifically, the 19 kHz pilot carrier is important because once recreated, it becomes the cornerstone for decompressed MPX. The 19 kHz pilot carrier is necessary to lock audio and the 57 kHz RDS carrier to the correct phase. Furthermore, the decoder restores audio processing as explained in the previous slide. This is the only way to recreate an MPX output which is exactly the same at all µMPX decoder sites. Once the µMPX decoder has restored, the original MPX is there and can be connected to the transmitter. So since µMPX is progressing in technology, and since 2WCOM is at the forefront of technology, we are now releasing the latest µMPX version number 4. And this latest version includes increased bandwidth up to 800 kilobits, improved signal quality at the same bitrate compared to previous versions. And we're also working on upcoming firmware upgrades, including synchronous playout, which means that multiple µMPX over IP decoder are running synchronous. So this was about how it works and which upgrades are available. Let's go to the next topic, audio synchronization. Audio synchronization is essential for both audio over IP and MPX over IP or satellite networks. Let me explain. When car drivers travel, they do not want to be bothered with audio problems when driving through the area. We call the audio delay between two or more FM transmitters a delta delay. To overcome the situation, 2WCOM offers 3 different methods to avoid synchronization problems. Number 1, NTP or Network Time Protocol. Each MPX over IP decoder is synchronized by NTP. An active internet connection at the transmitter site is mandatory. NTP brings a delta delay below 10 milliseconds. This means that switching between 2 transmitter towers does not result in hearable audio differences. Number 2, PTP version 2 or Precision Time Protocol version 2 in accordance to the RFC 8173. This is an advanced synchronization method offering less than 1 millisecond delta delay. The MPX over IP encoder generates a timing signal which must be carried through the IP network to all MPX over IP decoders. The IP switches and routers in the IP network have to be PTP version 2 compliant. And last but not least, GPS 1PPS. This offers microsecond accuracy and allows the radio stations to operate the network in a highly sophisticated single frequency network mode. This requires a GPS clock generator on each transmitter station. For real single frequency network operation, the whole distribution chain, including transmitters, have to be synchronized by a GPS clock. Now, this may be one of the most important parts when transporting MPX over IP or over satellite. To overcome this potential risk, as mentioned before, any disturbance in the transporting of IP can have a huge effect on the FM deviation at the transmitter side. This will also have a negative effect on the audio quality. To overcome this potential risk, 2WCOM offers following solutions. There are two major challenges: jitter and connection problems. Jitter and connection protection. This can be solved by using dual streaming via two separate IP feeds and intelligent buffer management at the decoder. If the primary stream is interrupted, the decoder switches automatically to the second IP stream and vice versa. Lost packet protection. This can be solved by intelligent error correction, such as µMPX or secure reliable transport methods like SRT or RIST. A proven mechanism is the µMPX error protection. The error protection is based on the fact that the send packets are organized in a matrix structure at the encoder in order to calculate correction packets over the rows and columns. The latest and very robust way of protection are called SRT and RIST. Both are designed for secure, reliable transport. SRT requires a bidirectional IP connection. In case of µMPX over satellite, the µMPX forward error correction can be activated to make secure and robust transmission. So before we are coming to the conclusion of this webinar, let's take a snapshot from the MPX2DS in two use cases. The upper block diagram shows a full-featured two-channel µMPX decoder with satellite tuner. It shows the MPX2DS when decoding two separate MPX radio services from satellite. The MPX2DS decompresses the µMPX to MPX and outputs them as analog and digital MPX. Number two, the lower block diagram shows a fully featured two-channel µMPX decoder with satellite tuner and regional switch. It shows the MPX2DS when decoding one MPX radio service from satellite. The MPX2DS decompresses the µMPX to MPX and outputs it as analog and digital MPX. The second µMPX decoder can be used for feeding a regional radio service. The MPX2DS has an integrated MPX switch, allowing the broadcasters to switch between national and regional program. All blocks marked in orange are features which can be activated at any moment in time via a software license. This makes the MPX2DS the most advanced and flexible MPX over satellite receiver decoder. So that was a lot of information to digest, but don't worry, we are almost there. We are now coming to the conclusion of this webinar. Let's recall the pros and cons of MPX over IP. The pros are very clear. The radio station can make more use of the capabilities of the IP or satellite transportation network. Especially the dynamic sound processing at the studio site allows the radio station to generate more revenue from the advertisers, while at the same time offering more dynamic sound to the listeners. Also for CAPEX and OPEX, the new MPX over IP technology brings much more benefit. By implementing state-of-the-art error protection, we are able to take away the cons and upgrade your MPX distribution to an impressive level. The solution 2WCOM offers is called MPX2C codec and MPX2DS MPX over satellite decoder. This state-of-the-art technology offers MPX codec, RDS generator, stereo generator, advanced transmission robustness, and the latest µMPX compressed MPX technology in only one 19-inch rack unit. And let's not forget a very important topic for broadcasters and service providers. µMPX is offered by many vendors and therefore has been established as the de facto world standard for compressed MPX over IP and satellite. So now we have explained the decoder and receiver section as well. Many questions may be raised in your mind, which is good because we're now ready to answer your questions. So please use the question chat button in the GoToWebinar application to state your questions. We will answer your questions without mentioning your name, so don't be shy and state your questions. Anke, would you take over?
Yes, for sure, I will take over. I'm just looking for the questions, and I want to welcome my colleagues Henrik Busse and Jos Schulke. Both are experts for MPX over IP and over satellite distribution, and yes, know our devices very well. And I think they will be open for your questions. So feel free to ask directly. I'm going to unmute Yes, you can just type your questions, or you can even ask directly. Okay, I think
it looks like the presentation was quite clear. Not much questions, I guess, Enke, correct?
I mean, that is what Oliver Herbst is saying. We no questions because of a very good and informative presentation. So this is a good compliment.
Okay, if there are no any questions, then I think we can go to the last section. So on behalf of my colleagues Enke Schneider, Hendrik Bussler, Jo Schulke, and the 2W.com, we would like to thank you for your attention. At your screen, you will see the contact details from us. So you can always free to send us an email or contact us by phone, no problem at all. After the webinar, you will receive a YouTube link from the presentation and datasheets from 2W.com MPX over IP products. So, and do not hesitate to contact us in case you have any questions or you'd like to have more information. So, thank you very much for your attention. I wish you a very good day, and since it's Friday, a very nice weekend, and up to the next meeting or next webinar. Thank you very much. Bye-bye.